Okay, so now I have y squared minus x squared over y squared. Of course, that's illegal, so I'll multiply top and bottom by y because I don't want to have fractions and fractions. I want to kill those denominators. So I have y squared minus x squared over y cubed. And then I notice that I have something very similar to this numerator back at the very beginning. The only difference is that subtraction is in a different order. Could I turn that so that I don't have subtraction in that order? And I think I can, because I learned back in Algebra 2 that if I pull out a negative, it changes the order of those terms. So now I can plug in a negative 16, because if I divided both sides up there by negative 1, then I'd have y squared minus x squared by itself, and it would equal a negative 16. So I get negative 16 over y cubed. Isn't that beautiful? Now, here's what you need to note when you're doing the second derivatives. So I want you to pause the video and write down this little note. Is when you're taking the second derivative, you are going to have to substitute in for dy dx at some point in order to get it out of there and simplify. And also, you're going to have to substitute in for one or both variables, the x's and the y's, again, in order to simplify. So you want to keep on the lookout for that. Remember, it's really about equivalent values. So if you saw this on a multiple choice and this answer wasn't there, you would want to figure out how did they get rid of these, and you can do that by going back and checking to see, did I have this information anywhere that led to this? So it's kind of like being on a scavenger hunt. So on this last one, I want the equation for the tangent line. In order, remember, to get the equation of a tangent line, I need two things, a point and a slope. So clearly, I already have the point. Now I have to find the slope, and in order to find the slope, I've got to do first derivative. But when I try to take the derivative of this, I notice, ooh, that's icky, I can't get y by itself, so I'm going to have to take the derivative implicitly. So again, I'm powering down the first term, and then taking the derivative with respect to x. Oopsies! That's equal to 1 again, so I don't need to write it. And then I'll take the derivative of the second term, which will be 2y dy dx. Those don't match, that doesn't cancel out, equals 9. Now I want to get dy dx by itself. Pause the video and you try it this time. So hopefully you noticed this mistake and you fixed it, because the derivative of 9, of course, is 0, not 9. And so when you solve, you get that the slope of the tangent is negative x over y. And so now at the point 0, 3, I'm going to plug in the values, and so I get a slope of 0. So now the equation of the tangent line would be y minus 3 equals 0 times x minus 0, and I could simplify that all the way to y equals 3. So there's the tangent line. Then I'm supposed to do the equation of the normal, and a normal line is a line that's perpendicular to the tangent. That's pretty much all you need to know. You should have learned it in pre-calc, but your teacher might not have taught it to you. So a normal line is perpendicular to a tangent, and we know that if they're perpendicular, their slopes have to be negative reciprocals. So the negative reciprocal would be negative 3 over 0, but that's undefined. So if I have an undefined slope, I must have a vertical normal line, and if the normal line is vertical, it has to be an x equals, and I already know the value of x. It was 0. All done.